Good evening. I had some questions about Algebra 2, Lesson 2 on absolute value. And let's talk a little bit about what absolute value is. I'm going to run a quick PowerPoint for you. The first thing I want to talk about is what exactly is absolute value. Um, I want to, there we go. The absolute value of a number is the number of units it is from zero on the number line. So if you have a number line, and let's say you have the number -8, if you go from 0 to -8, you're basically moving 8 spaces to the left. If you are going to pinpoint on the number line the number 8, a +8, it's also 8 spaces from 0. So what you need to think about is absolute value means how far from 0. Um, if you have two numbers like 5 and -5, they both have the same absolute value because no distances are negative. So even if you're going to -5 on the left side, you're just going on the left side of the number line from 0, and it's still 5 spaces. It's still a whole number 5. Um, so you have to keep that in mind when you're trying to solve these problems. The symbol for absolute value that helps you with the definition are two lines straight up and down. So the way I would read this is I would say, what is the absolute value of x? And remember, x can be either a positive or a negative. The definition means how far is this number from 0? And it's never going to be a negative number. So remember that the absolute value of a number is its distance from 0 on the number line. Since we cannot have negative distances, absolute values are always going to be positive. So if I have the absolute value of -8, that's +8. The absolute value of +4 is 4. And you try these. So what would be the absolute value of a +15? I hope you said +15. And what would the absolute value of -23 be? It would be 23. So remember that if you have a number, if your a is greater than 0, its absolute value is going to be whatever a is from the distance from 0. And the same is for negative numbers. It's going to be whatever a is, the distance from 0. And because it's a distance, the absolute value itself is not going to be a negative number. Now, that does not mean that when you're solving absolute value equations that you may not get a negative number. So let's talk about negatives briefly here. And hopefully you have reviewed your positive and negative rules so that when you're doing these equations, you're going to be able to solve them. Anytime you see a negative that's outside of the absolute value symbols that are straight up and down, then you need to treat that negative as a -1, that you're multiplying or dividing by a -1. So let me give you some examples. So if you have the absolute value of 6, but on the outside it says negative the absolute value of 6. Well, we know the absolute value of 6 is going to be 6. But when I multiply that by a -1, I'm going to get an overall answer of -6 because the absolute value part is just the whole number 6. But this negative indicates that you have a -1 here. the absolute value of -4 times a negative is going to be 4 here for the absolute value, and then you're going to actually be multiplying that by -1. So the absolute value of -4 is 4, but because you have this negative on the outside of the absolute value, that means that you're multiplying, because they're side by side, that means you're multiplying by a -1. And we know that -1 times a +4 gives us a -4. Very similar to the first problem. Now, in this particular absolute value equation, we need to evaluate what's inside the absolute value. What you want to do is treat it like it's a parenthesis. So you want to kind of take care of that first so it's not so messy. Think of it as a parenthesis, something that you need to go to right away. But because there's a negative on the outside, think of that together as a multiplication when you're doing your order of operations. So inside the parentheses, we have -5 minus a -2. Well, we know with our integer rules, anytime you're subtracting an integer, you need to take plus its opposite. So this is the same as -5 plus a +2. Well, if I'm -5 and then I go plus a +2, I'm going to end up with a -3. But we know because that -3 is inside of the absolute value, it's really a +3. So let's go ahead and review that again. -5 plus a +2 gives me a -3. That -3 becomes a +3 because it's the absolute value of -3. How far from 0 is -3? It's 3 spaces. So that's why this 3 here is positive. Then you have this negative hanging outside the absolute value. So because you have this negative hanging out here, that's the same as writing a -1. And I know that -1 times a +3 is a -3. So I've got two problems here I want you to try. You can stop the video and go ahead and try them. I am going to tell you what the answers are. So remember, you treat the absolute value like it's a parentheses. Go ahead and stop the video and do these. All right, let's go over the answers. So -8 minus 10 is the same as a -18. So inside the parentheses, inside the absolute value, I've got parentheses on mine now. Inside the absolute value, I get a -18, which I know is +18 because it's an absolute value symbol. And I know that the negative out here turns to -1. So -1 times the +18 that we got from the absolute value gives me an answer of -18. Now, likewise on this last one here, inside the absolute value, we have -12 plus 2. So we know we have a positive and a negative. We have to take the difference between them, and we use the sign for the one furthest from 0. In this case, it's going to be 12 minus 2 is 10. It's going to be a -10 inside of that absolute value. So because that's a -10 inside of that absolute value, I know that -10 is 10 spaces from 0. So the minus or the negative on the outside is going to be represented by -1. And then on the inside here, I've got a +10 because that's how many spaces from 0 -10 is. And then when I multiply the two together, I get -10. So slow down, make sure that you're taking care of your signs correctly. Otherwise, you can end up with the wrong answer. Okay, just be careful. And also review your signed numbers that we did in Algebra 1 under Foundations. If you forgot those rules, you might want to review them. Okay, so let's evaluate some expressions that have absolute value symbols in them so that you can get a little practice. Remember, these vertical bars going up and down, they are grouping symbols. Think of them as like parentheses, something that you need to go to and take care of right away. And remember what absolute value means, how far from zero. So you'll evaluate what's ever inside of it. So in this particular one here, I have an absolute value, and then I have that absolute value being summed with a 5. And when you have situations like this, and they tell you what x is, this is going to be easy to solve because all you're going to do is use substitution like every good algebra student knows. You're just going to take that -2 and substitute where the x is. So if you did that, 9 times a -2 is a -18, and then that -18 is going to be subtracted. So you get a -21, which is going to be what? You should get positive. Well, eventually you'll get a positive 21, but you're going to get -18 minus 3, which is -21. And then the absolute value of -21, once you've evaluated what's inside, it's going to give you the whole number 21 that you're going to add to 5. And then when you take that 21 and add it to 5, you're going to get 26. So you see, you have to make sure that you are evaluating in the right order, using your order of operations, and that you understand what's inside of those vertical bars is considered absolute value, and it's how far from zero. It's not going to be, quote unquote, a negative number. There's no negative on the outside of this. So, and this number is not larger or negative. So you're going to just add those two together and you get positive 26. Now, there are some steps that you need to keep in mind when you have absolute value expressions that you need to evaluate, not through substitution, but actually discovering what the answer to the absolute value would be. One thing you have to keep in mind is the absolute value as its own expression needs to be isolated by itself on one side of the equation, very similar to what we do with variables. And then you need to set the quantities for the absolute value to both a positive answer and a negative answer, because as you can see, if I use -11, the absolute value of -11 is still 11 spaces, but the 11 itself is negative. And the absolute value of positive 11 is also 11. I'm sorry, let me go back. Let me see if I can go back. So you're going to isolate that variable first. Then you're going to set the equations up. It's going to be 2. So sometimes in these equations you have 2. Sometimes you can get one answer, and sometimes based on the problem, it could have no solution. So most of the problems that I gave you will have a solution. So we're going to actually do an example. So if we have x is equal to 3, we know that that x inside the absolute value can be both positive or -3. That's the solution to that particular equation. So let's actually work out one, keeping in mind that we have to write two equations, one for the positive answer, one for the negative answer. We need to solve those. And the best way to know you're right in algebra is to check your answers by using substitution. So here's an example that we're going to try. If you look at this problem, solve x plus 8 absolute value equals 3. we do already see that the absolute value has already been isolated on one side of the equation. So I don't have any extra work to do to get that isolated. It's already done. So what I'm going to do is I'm going to take that absolute value equation. I'm going to keep it at a positive 3, and then I'm going to also solve it with a negative 3 because I need to get both sides of the absolute value. So when I do that, I'm going to get x is equal to a negative 5 with the positive 3, and x is equal to negative 11 with the negative 3. And let's just review how we did that. To get the x by itself and isolate it, you're going to basically subtract both sides by negative 8, or subtract both sides by 8. I'm sorry. So 8 minus 8 is 0. That leaves you just with an x on this side, which is what you want. You want it isolated. And then 3 minus 8 gives you negative 5. So you're going to get x is equal to negative 5 as your first solution. On the second solution, you're going to take the 8 again, subtract it from both sides. But in this case, you're going to get 0 on the left. So you have x by itself, which is what we want. Because this is negative 3 in this case, negative 3 minus negative 8, or plus a negative 8, same thing as minus 8, that's going to give you a negative 11. So don't forget that if you have a negative 3 and you subtract 8, that's the same as negative 3 plus a negative 8, which gives you a negative 11. So you have to remember those rules. Now let's just check it. All we're going to do is substitute these in to make sure they're right. So in the absolute value, go back to this original problem here. Stick in the negative 5. So we know that negative 5 plus 8 gives me a positive 3. That's what I tested for, and that's correct. And in this one, negative 11, when I substitute negative 11 for x, and I add that to 8, I'm going to get inside a negative 3, and then negative 3's absolute value is also 3. So as long as you get 3 for the answer, you're good. So you can check those off. And it's always a good idea to check your answers to make sure that you're doing it right. You don't have to go, Misty, Misty, am I right? You can figure it out yourself, okay? Now try these. This one, remember, it's not isolated. The absolute value is combined on this side with negative 3, so you're going to have to do plus 3 first. And that will leave you with y plus 4 equals 3 when you do that. Then you want to, because the absolute value is isolated, you're going to go ahead and do your two equations. One is going to be absolute value of y plus 4 is equal to positive 3, and the other one is going to be y plus, the absolute value of y plus 4 equals a negative 3. And then you're just going to solve them. So there are my two equations. You're going to solve them. For this one, what you had to do to isolate the y was subtract 4 from both sides, which leaves you with negative 1. And on this one with the negative 3, you had to subtract 4 from both sides again. And in this case, you're going to get negative 7 because you have negative 3 plus a negative 4, or negative 3 minus 4, same thing, equals negative 7. And then you want to check your answer. Just substitute negative 1, and you're going to get 3 for your absolute value. And that's going to be 3. And it looks like here they just went ahead and put it in and with the original. So the absolute value of negative 3 is 3. And in this case, it actually should be positive 3, which is 0. Okay, so 3 minus 3 is 0. And the absolute value here for the negative 3 is going to also be 3, which is 0. So they both check. Okay, so yeah, 3 minus 3, 0, 3 minus 3, 0, they both check. All right, so here we have to isolate the absolute value first, and the way we'll do that is subtract it by 6. And that'll leave me with the absolute value of 3d minus 9 equals a negative 6. And we'll set two equations up, one using negative 6 and one using positive 6, because we have to get the opposite of it as well. Now, why would I not need to do this on both sides? Because the absolute value is never negative. So if you get a negative answer, when you isolate the variable, you can stop. And this is one where you have no solution. So like I said, you can have one that's no solution. You can have one that's two solutions. You can have one that's one solution, because depending on whether it gives you a 0. All right. All right, now let's isolate this one. And on this one, you're going to go, because 3 is being multiplied by the absolute value, it hasn't been isolated yet. So you have to divide by 3 on both sides. And then once you have that absolute value isolated, you're going to do positive 4 and a negative 4. And when you solve, you're going to get 9 for this one and 1 for this one, because what you had to do was add 5 to both sides. You get 9. Add 5 to both sides. 5 plus a negative 4 is 1. Go ahead and check it. Substitute 9, and you're going to get 3 times 4 is 12. And then on this side, you're going to substitute the 1, and you get negative 4, which equals 12. And it checks out. Okay, now the variable is not isolated on this one at all. So we are going to, first of all, take the answer that's got the variable in it. There's no absolute value on this at all. So what we're going to do when we have other variables on the same side, but it's still the same variable that you're solving for, we're going to take the original of it in its original form, and then we're taking the opposite of it. So in this one, I just put the whole parentheses and then a negative on the outside for negative 1 to show that I'm doing the opposite of it. Now, set your two equations up. That's what we did. Then you want to start solving them. You want to combine like terms when you're solving for a variable. So what I did here is I just rewrote it, but I did have to do some work here because I had a negative 1 on the outside to do the opposite. So that gave me negative 14, and then the opposite of negative a is positive a. So now that I've gotten it to a form that I can actually manipulate, the first thing I did was combine the a's. So to get rid of this negative a here and move it over there, I have to do the opposite, which is plus a. So 5a plus 1a is 6a's. And then I took the 8, which is positive, subtract 8 from 14, you get 6. Then you're going to divide by 6 on both sides, so your a on this side is going to be 1. In this one, we're going to do the same thing. We're going to move the A over, but because this is addition, the opposite is to subtract. So we subtract A, and we get 4A to move them together. And then we're going to do the same things with the constants. You take 8, and you're going to be subtracting 8 from negative 14, which gives you negative 22. Divide by 4 on both sides, and that leaves you with A all by itself like we want. And then when you divide 4 into negative 22, you get a negative 5.5 or negative 5.5. So what we have to do is just stick those back in the formula and check them. On this one, we're going to use 1 to check. So 8 plus 5 times 1 is equal to 14 minus 1. And that's 13, the absolute value of 13, which is 13. And then here, we're going to put negative 5.5 when we multiply these two together, and then add 8, which is basically taking the difference. We get negative 19.5 inside the absolute value, which can't be negative, so it's going to be 19.5 positive and 19.5 positive. So the two sides are equal. And you have two solutions. Now, these are problems. The next three problems are from your homework. You can find these in your homework. This first one is just basically a substitution question. You have the function, and then this function, you have the absolute value of x minus whole number 3. And what they want you to do is just solve for the negative 3 at this function. Well, if I stick negative 3 in this absolute value, that negative 3 becomes a positive 3. So the absolute value of negative 3 is positive 3. Then I subtract 3 to continue the expression. And I know 3 minus 3 is 0. So the solution for that is 0. On the second problem, you're given the absolute value of 5 minus r is equal to 2. And so you want to figure out what r is. You already have the absolute value itself isolated on one side of the equation, so just write up your two equations. One is going to be with a positive 2 for the answer, and one's going to be with a negative 2 for the answer to take care of your distances. When I solve for the positive 2, I'm going to get that I get a negative r when I move the 2 over, the 5 over. I subtracted the 5. Then I get negative r is equal to negative 3. Well, we can't have a negative r in our variable. We have to divide that by negative 1. So we get r is equal to 3. And then on this one, we had 5 minus r is equal to negative 2, because this is the negative side of it. And in here, when I subtracted 5 again, I got negative r is equal to negative 2 minus 5, which is negative 7. Well, again, I cannot have the negative side of the variable. I need to know what r is. Well, r is going to be 7. So you should have a positive 3 and a positive 7 for the answer to this problem. And then what you would do is just go back up here and substitute and see what you got. So if r is 3, 5 minus 3 is 2. That's true. If r is 7, 5 minus 7 is negative 2. The absolute value of negative 2 is 2. So they both check. And this is the last one I did. And this is also one of your homework problems. I don't remember what number it is. But this absolute value expression inside of this equation is not isolated. So you need to do that work first. First thing we're going to do is subtract 10 from both sides. And then after we subtract 10 from both sides, we're going to be left with negative 3 times the absolute value of 9m plus 2. And I got 0. The reason I get 0 is because when I take 10 minus 10, I got 0. So the next thing I need to do to isolate this is this -3 is being multiplied by the absolute value. Well, to get rid of it, I have to do the opposite, which is divide. So I'm dividing by -3 on both sides of each equation. And when I do that, that leaves me with 9m plus 2 in the absolute value. It's been isolated. Now notice the answer for this isolation is 0. I am not going to have, I don't have a number there, so I'm not going to have a two solution problem here. So I'm just going to set this equal to 0 because it's going to be only one solution, because 0 does not have any signs. So when I solve this, and just remember, if when you isolate your variable, you just have a negative number, you're done. The answer will be no solution. And if you isolate your absolute value and you have 0, only 0 on the side for the equality, then you're only going to have one answer. And that one answer you have to solve for. So I'm just going to say 9m plus 2 is equal to 0 and see what I get. So when I do 9m plus 2 equals 0, first I have to get rid of the 2 by subtracting 2 on both sides. And that leaves me with 9m is equal to -2. And then I have to divide that 9m by 9 so that I can isolate m. And when I do that from both sides, I get m is equal to -2 over 9. And I'm going to just leave it as a fraction instead of make it decimal. So we can go back and check this. If we put a -2 over 9, this is going to give me a -2. So -2 plus a +2 is 0. -3 times 0 gives me 0. And then when I do the 0 plus 10, I get 10. So 10 over 10 is equal to 10. This checks. So you can check all your answers and make sure that they're right. Okay. Now, if this quick review, you're still having a little bit of trouble, just let me know. We can set up a Zoom meeting on any of the problems that you have questions about, or you can send me an email and I can show you what the solutions are via email. I have no problem with doing that for you as well. So if you don't have time to sit down and Zoom meet with me, but you get the gist of this, I can go ahead and do a problem from your homework or from your practice that you got stuck on. Thanks for being with me today. I'm going to stop sharing and have a good evening.